This is AB Calculus second 6 weeks test for fall 2015. I earlier recorded part 1, which are the first 6 problems which have to do with the differentiation. We're going to go on with problem 7 onward, which I hope is this part 2 is the rest of this test review. Problem 7, test to see the function below is continuous and differentiable for all x. Justify. Well, for continuity, we have 3 conditions we need to meet, and if those conditions hold, we can go on to differentiability. But we know we can't go on to differentiability unless we have demonstrated we have continuity first. And so the first step in continuity is to find out if the function exists, and we say g of, and our critical value here is 1. G of 1 exists. And how do we know that g of 1 exists? Because g of x is defined as x plus 1 when x is greater than or equal to 1. So we say and is equal to, we plug in 1 plus 1 is equal to 2, because if we plug in 2 for this x, plug in 1 for this x plus 1, we get an output of 2. We test for that the limit exists. For limit to exist, the limit as x approaches 1 from the left side of g of x has to equal to the limit as x approaches 1 from the right side of g of x. And from the left side, we have this x squared plus 1. So from the left side, we just write this as 1 squared plus 1 is equal to, and on the right side, we have x plus 1, so that'd be 1 plus 1. So we have 2 equals 2. So we say the limit as x approaches 1 of g of x exists and is equal to 2. Yeah, 2 equals 2, right? Equals 2. And so the third condition we try for is, we say g of 1 equals limit as x approaches 1 of g of x, which equals 2. Therefore, g of x is continuous at x equals 1. And really that's the only critical number. Otherwise, x plus 1 on the right side, x squared plus 1 on the left side of 1 are polynomial functions. Now we test for differentiability. I'll say differentiability. Yeah, that's right. And then say 1, first condition is g of x is continuous at x equals 1. We've already demonstrated that. 2, the limit as x approaches 1 from the left side of not g of x but g prime of x is equal limit as x approaches 1 from the right side of g prime of x. And so from the left side, we have this x squared plus 1. So we have g prime of x is going to be 2x. And on the right side, we have the derivative, we have x plus 1, and the derivative of x plus 1 is 1. And now we plug in 1 to both sides. We have 2 times 1 is equal to 1. 2 is equal to 1. 2 does not equal 1. So the limit as x approaches 1 of g prime of x does not exist. Therefore, g of x is not differentiable. And I had some students who got this pretty close to right. I was pretty liberal giving credit. But this is really what the thing should look like. And graphically, what the thing looks like is this, that we have this function here, this piecewise function, and the critical value is x equals 1. And we know that at x equals 2, right here at x equals 2, the functions join up, because from the right side we have this x plus 1 that looks like this. On the left side we have this x squared plus 1 that looks like this. Okay, what's happening right at this juncture is, while we have continuity, from the left side the slope is 2, from the right side the slope is 1, and so there's a corner, a sharp corner, and that disqualifies the differentiability. Problem 8, table showing certain values for f of x is shown below, and we have the table values, and then we have what is the limit as x approaches 3 of f of x. And from the left side, what are we approaching? Well, we have 3.9, 3.99, 3.999. We're approaching 4 from the left side. And from the right side, we have 4.1, 4.01, 4.001. We're also approaching 4. And so our answer to this question is 4. And even though f of 3 is defined as 25, the limit as x approaches 3 of f of x is 4. Next, the function v of t over the interval ab is continuous and represents the velocity of a particle. If v of a equals 1 and v of b equals -2 and f of c equals k, for an input value of c on the interval open interval a to b, what is the value of k that guarantees the speed of the particle will be exactly 4 at least twice? So for that, if we just draw a graph where we have here velocity, and we just have the input value, we'll just say, we can say x, or t, it says t, right? V of t, we'll just call it t. Okay, so at input of a and input of b, we have f of a equals 1, which is right here, and f of b equals -2, which is right here. And so what we have is we have to get from a to b, and we're asking, what is the value of k that guarantees the speed of the particle will be exactly 4 at least twice? So we say value of c right here, and we're going to go ahead and draw in these values of k in the answer choices. Well, at a, okay, answer choice A is right up here where velocity equals 4. So I'm going to just label answer choice A. Answer choice B is 0. Answer choice C is -5, so that's -3, -4, -5. So here's answer choice C down below at -5. And then we have answer choice D at 3. And finally, answer choice E at -3. Well, if we look for where the speed of the particle is 4, we can go here horizontally at 4. And for answer choice A, the problem is to get from this f of A, or v of A, to v of B, and to touch A, we only have to cross once. But here's the concept. If we go down here, the intermediate value theorem says that if k is value of c, we have to go through this value of -4, touch at least twice. Why? The intermediate value theorem. And why is that? The speed equals absolute value of velocity. So we have at -4, this is a speed of 4, even though the number is -4. And so our correct answer is C. So testing your understanding of the intermediate value theorem, and also that speed is the absolute value of velocity. For the function f of x equals 2x squared minus 14x, find the equation of the tangent line at the point where f prime of x equals 10. 2 points. So first thing we're going to do is find f prime of x, which is 4x, right, 2 times 2 is 4x to the 2 minus 1, minus 14. We're going to try to find at the point where f prime of x equals 10. So we take this f prime of x, set this equal to 10, so 10 equals 4x minus 14, and so we add 14 to both sides. We have 24 equals 4x, and then we have x equals 6. And so we need a point to find this, the equation of tangent line. And our point, we have an input value of 6, and our slope is already given to us, which is m sub t equals 10. So we have that. And then to find our y value, we need to take our original equation. We'll say f of 6 is equal to 2 times 6 squared minus 14 times 6. And that's going to be 2 times 36. Let's try 2 times 36. Let's be minus 14 times 6. Like 14 times 6 so it's going to be 24. 6 times 1, 84. Minus 84. So f of 6 equals 72 minus 84, which equals -12. So our point is 6 comma -12, and therefore our equation is going to be y minus -12, which is plus 12, equals 6, equals 10, excuse me, 10 times x minus 6. And we box this in as our correct answer. Once again, in point slope form. Next problem, 11. For the function f of x equals the square root of 20x plus 2, tell whether Rolle's theorem or mean value theorem applies on the interval from -2 to 7. So to test that, we're going to find out f of 7 is going to be equal to square root of 7 plus 2, which equals square root of 9, which equals 3. And then f of -2, excuse me, -2 is going to be f of -2 is equal to square root of -2 plus 2, which equals square root of 0, which equals 0. And so since f of 7 is not equal to f of -2, mean value theorem applies. Rolle's theorem would only apply if these were the same thing. And also, the function is continuous between -2 and 7. Also, f is continuous, and this is a square root curve and differentiable on open interval -2 to 7. So mean value theorem applies. That's going to be a point there. If so, find the value of C that satisfies the conclusion of the mean value theorem. Well, first of all, then we're going to find the average rate of change, which is going to be f of B, which is 3, minus f of A, which is 0, over over B, which is 7, minus -2. And so we're going to get 3/9, which equals 1/3. And so that's another point there. Next thing we do is take the derivative of this function. So that's going to be f prime of x is equal to this x plus 2 is the square root of x plus 2 is to the 1/2 power. So we have 1/2. We have x plus 2 to the -1/2, and times the derivative using the chain rule, make that to the -1/2 power, and times the derivative of the inside, which is 1. So this is going to simplify to 1 over 2 square root of x plus 2. And what we're going to do is set this equal to 1/3. So we say 1/3 is equal to 1 over 2 square root of x plus 2. And for this to be true, we would have to have 2 times square root of x plus 2 is equal to 3. And dividing by 2, just go on the right here, we have square root of x plus 2 equals 3/2. And squaring both sides, we have x plus 2 is equal to 3 squared is 9 over 2 squared, which is 4. So x plus 2 equals 9/4. Well, when we subtract 2 from both sides of the equation, we're going to have x equals 1/4. So that would be our, so I'm looking for three things. I'm looking for that value of C that satisfies, which is x equals 1/4. We're looking for the average rate of change, which is 1/3. And then we're looking for this argument about mean value theorem versus Rolle's theorem. So those are the three components. For the function g of x equals absolute value of x minus 2, g of -3 equals 1, and g of 3 equals 1. Tell if Rolle's theorem applies. So since g of 3 equals g of -3, then Rolle's theorem applies. If they are the same, Rolle's theorem. If they're different, mean value theorem. Okay, but does it really apply? Let's go ahead and look at this. If we have this absolute value function, which is the absolute value of x minus 2, and so it's going to be like this. Absolute value function, and here we have 3, -3. So these things are equal right here, and so Rolle's theorem would say that there's a point where the slope between them is 0. But what's happening here? Okay, since there is a corner or sharp turn, Rolle's theorem does not apply. So Rolle's theorem does not apply because of this. And indeed, if we tried to take the derivative, we wouldn't get a derivative of the average rate of change being 0, or an instantaneous rate of change being 0, because there's a corner. There's no place on this function that the instantaneous rate of change is 0, or we have a horizontal tangent line. Let's see, and box this in is correct. Next, 13, for the function f of x equals x squared minus 4, find the equation of a normal line for the graph of the function at the point where x equals 2. Before that, we need two things. We need a point, and that point is going to be 2 something. We need a slope. Okay, well, to find our point, we put in f of 2. That's going to be equal to 2 squared minus 4, which equals 0. So we have 2 comma 0. And our slope is going to be, well, we take f prime of x is equal to 2x, period. And so f prime of 2 is going to be 2 times 2 equals 4, which equals m sub t. Well, m sub n is the negative reciprocal, which is going to be negative 1/4. So slope, we say m sub n equals negative 1/4. So our equation is going to be y minus y sub 1, which is 0, equals negative 1/4 x minus 2. And if we distribute, we get negative 1/4 x plus 1/2. Anyway, this will be our answer. Next problem. 14. The table below has the recordings of depth of river above flood stage taken during 18 hours after a recent rain. What is the estimate of the rate of water level increase at t equals 10 hours? So we're interested in this time frame here between hour 9 and hour 12, and for that we're going to use our average rate of change concept, which is f of b minus f of a over b minus a. And in this instance, we have b is going to be, we'll call b our 17, and we'll call a our 15. So we have 17 minus 15 in the denominator, and we have 12 minus 9 in the numerator, so 12 minus, so I have it backwards, just like one of my students did. Okay, actually b is going to be 12, and a is going to be 9. So we have 12 minus 9 in the denominator, and we have 17 minus 15 in the numerator. So we're going to have 2 over 3, which is 2/3, and that's going to be feet per hour. So an increase in feet per hour. Okay, as I was about to do, you got to be careful because you can easily mix this up and get 3 over 2. What's the limit as x approaches infinity of negative 5x to the 4th power plus 3x squared plus 10,000 over 2x squared minus 2x to the 4th power? So we look for commonalities in the numerator and denominator, and we see we have our highest power of these polynomial functions on either numerator or denominator is going to be this x to the 4th power, and x to the fourth power here in the denominator. So our limit is going to be this negative 5x to the fourth over negative 2x to the fourth. And why? Because compared to these two ones I circled, the rest just pale in comparison. So it's like when you get close to infinity, it's like these other things don't even matter. So we can just simplify, and x to the fourth over x to the fourth cancel. So we have negative 5 over negative 2. And guys, don't leave it like this. Come on, you know negative 5 by negative is positive, so you have 5 over half. And you can decimalize if you want to, but there's no reason to. It could be 2.5, but just leave it fractional form. 16, what is the limit as x approaches 5 of x minus 5 over x squared plus 4x minus 15? If we plug in 5, in the numerator we get 5 minus 5. In the denominator we get 5 squared, which is 25, plus 20, and 25 plus 20 is 45, minus 45, we get 0 over 0. So we need to do more work, and to do that we're going to go ahead and factor this denominator, and for x minus 5 to be cancelable, we would have to have one of the factors in the denominator be x minus 5, 20x minus 5. And what times x minus 5 equals x squared plus 4x minus 45? Well, that's going to be simply x. Let's see, what times 5 equals 45? It's going to be 9. And so we have x minus 5 over x minus 5 cancel. And so now we have the limit as x approaches 5 of 1 over x plus 9, which equals 1 over 5 plus 9, which equals 1/14. Guys, I have some news for you. Some of the answers I see, it may not dawn on you. Okay, I will give you some news. 1 over 14 is not equal to 14. All right, our answer is 1/14, not 14. 17, find the horizontal tangent line or lines beneath the graph of the function f of x equals 1/2 x squared minus 2x. Well, first step, we'll find the derivative, and do that of this function. We'll put f prime of x is equal to, we take 2 times 1/2, which is just going to be 1, and it's going to be x to the 1 power, and the derivative of negative 2x is minus 2. And so we set this derivative equal to 0, so we say 0 equals x minus 2, and solving for x is equal to 2. And so we do have a horizontal tangent line where x equals 2. And the next thing we need to do is find f of 2. Just plug in 2 to the original equation, and we get 1/2 of 2 squared, in parentheses, minus 2 times 2. And 1/2 of 2 squared is 4 over 2 minus 4, which equals 2 minus 4, which equals negative 2. So f of 2 equals negative 2. And so our horizontal tangent line is y equals negative 2. Now I give points along the way for different things, finding a derivative, setting that, plugging in, and so forth. Next problem, 18, what is the limit as h approaches 0 of 3 times 20x plus h squared minus 2 times 20x plus h minus 23x squared minus 2x. And so according to the form of definition of derivative, which is limit as h approaches 0 of f of x plus h minus f of x over h, that according to this format, f of x is going to be this thing right here. So before that, sometimes they'll not have this in parentheses and make it a little more complicated, but here f of x is going to be equal to 3x squared minus 2x, and therefore f prime of x is going to be equal to 6x minus 2. And if you didn't pick this up, you could have gone through with the definition of derivative and made this long. You could have simplified and all that. You've come up with the same thing. Okay, next, use 19. Use a graph of h of x to answer problems 19 to 24, 1 point each. What is the limit as x approaches negative 4 of h of x? And so here we go over to negative 4. And it's pretty clear that our answer here is going to be negative 4. Next, 20. What is h of negative 1? So we go to negative 1, and at negative 1 it looks like we're just crossing the x-axis, so our answer to this one's going to be 0. 21. What is the limit as x approaches 2 of h of x? Well, here we have a 2, and we need the limit from the left side equal the limit from the right side. And since the limit as x approaches 2 from the left side of h of x does not equal limit as x approaches 2 from the right side of h of x, we conclude that limit does not exist. I'll just put DNE. DNE does not exist. Next, what is h of 2? Well, if we plug in 2, we have the function defined as 4. So 4 is our answer for h of 2. What is the limit as x approaches 4 of h of x? Well, as at 4, we have a vertical asymptote. So we could say infinity, right, for infinity, therefore does not exist. And the correct answer is does not exist. If you put infinity, that's not exactly the proper definition for the question. Now you could say it function does not exist because the limit from each side approaches infinity. But the answer would actually have to be does not exist. What is h of 4? Well, h of 4 obviously does not exist. The function is undefined at x equals 4. Next, 25. What is the limit as x approaches infinity of h of x? So here, as we go to the right, we have what looks to be kind of a horizontal asymptote. It looks like we're approaching 0. So, as we say, our answer to number 25 is 0. This function looks like it's flattening out against the x-axis. What type of discontinuity is evident at x equals 2? Well, that is a jump discontinuity. Jump discontinuity, okay? Not a point discontinuity, jump. Not an infinite discontinuity. Infinite discontinuity would be here at x equals 4. Next set of problems. Use the graphs of f of x and g of x to answer problems 27 through 33. What is g of x? Well, here's g and g of 4. What is g of 4? Well, we come at 4 and we go up here. It looks like our answer to this one is 2. Next problem. What is g prime of 6? Well, here we go up to g. We go to 6. And the first derivative is the slope of the original function. And we have this line segment here with the slope of 0. So our f g prime of 6 is 0. And if we wanted to, we could just take this equation. We could say for this segment of the function, the piecewise function, for x is greater than or equal to 4, we would have the function g of x is equal to 2. Well, if we take g prime of x at, what is the derivative of 2? 0. So just taking the derivative, we can convert this to an equation. That might be easier for some people to see. What is f prime of negative 3? And so now we go to the f function, and we go to negative 3. And again, we're looking at the slope. And this slope, the rise over run, at this point is going to be 1. Again, we could, if we made an equation out of this, we would have, for this segment on the left, we would have f of x is equal to x plus 4 across the x-axis, so f prime of x is going to be equal to 1. Next, what is f prime of 5? Well, f prime of 5, we go up here to 5, and we have a corner here. Because to the left of 5, we have a slope of, or an instantaneous rate of change of 0, and to the right, we have 1. So the slope of the point does not exist. Next, if h of x equals g of x, f of x times g of x, what is h prime of 2? So for this, we have an opportunity to use what we call a product rule. And we're going to say, we're going to have f of 2 is equal to, so we go to f of 2 is equal to 3, and f prime of 2, which is what we also need, is going to be equal to 0. G of 2 is going to be 0. Right, we go to function of 0. And g prime of 2 is equal to, the slope here of this part of g is 1. So h of x is going to be equal to f times g prime, so 3 times 1, plus g, which is 0, times f prime of, which is also 0, I believe, right? Yeah, so 0 is all the way around. So h prime of 2 is equal to 3. And I put here, made a little notation mistake. This should be h prime of 2 at this point. Okay, so this will be our answer. Next problem, we have if h of x equals f of x times g of x, what is h prime of 0? Well, here we have f of 0 is equal to 3. F prime of 0 is equal to, we have a horizontal line there, is equal to 0. Now g of 0 is equal to negative 2, and g prime of 0 is equal to, what is our slope here? Well, we have a corner, so our slope does not exist. Therefore, h prime of 0 does not exist. Next, if h of x equals g of x over f of x, what is h prime of 6? Well, for this, we have like low, and high. So low is going to be, we look at f of 6, right? And so we go up to 6, that's going to be 4, right? F of 6 equals 4. And the derivative of our low is going to be in 4, the slope of this thing is 1. And then high is going to be this thing at g, so we come over to 6. Well, that's going to be 2. And our derivative of our high is going to be which is the slope, which is 0. So h prime of x is equal to low times the derivative of the high. Well, low is going to be 4 times the derivative of the high, which is 0, minus high, and high is 2, times the derivative of the low, which is 4, and all over low squared, and low is 4, so we have 4 squared. So we have negative 8 over 4 squared, which is 64, and that's going to simplify to negative 1/8. So negative 1/8 is our answer for this one. Box that in a little more legibly. Okay, problem 34. What is the integral from 0 to 5 of 3x dx? Now we can rewrite this and take this 3 out front. So we're going to have 3 times the integral of 0 to 5 of x dx. So whatever we get from this integral from 0 to 5 of x dx, we can multiply that times 3 and get our answer. And for that, I'm just going to make a little sketch. We haven't gone over the rules of integration yet, but the concept of it you should have. Okay, we have this x, y equals x is going to be this diagonal line here, y equals x, and from 0 to 5, 1, 2, 3, 4, 5, and we're going to have this triangle with its base of 5, its height of 5, and its area under this line is going to be like this. So our area is going to be 5 times 5 over 2, which equals 25 halves. And then we have to multiply by this 3 out front, so we have 25 halves times 3 equals 75 halves. And that will be our answer, 75 over 2. Next will be our last problem. What is the intersection of y equals negative 11 and x equals 4? That's going to be the ordered pair of x equals 4 and y equals negative 11. We need to have 5 components for this to get this thing correct. We need opening parentheses and a closing parentheses. Those are 2 components. We need a comma separating the 2 digits. We need the digits to be right. Anyway, that concludes our test, and good luck in the review. And learn what you can from this, because there's a lot in here with all the differentiation that serve as building blocks. And if you're not mastering most of what we go over in this test, you're not in good shape going forward in this class. So good luck to you, and thanks for viewing.